So now at the end of the first year, how much does Madison have in her account? Right, so we started with the 10,000 and her interest payment is $500. So at the end of the year, she doesn't just have that 10,000, she now has the 10,500. And that's not bad for just letting the money sit in it, right? $500 to do nothing. I'll take it, right? Oops. Alright, so in question 2, it says Madison wants to record the amount of money she will have in her account at the end of each year. Complete the table below around the amounts to the nearest cent. So we have the first year she's depositing $10,000. After 1 year she has $10,500. After 2 years she's going to have $11,025. And so you want to fill in the rest of the table. So what are we doing each year? Well, in her account, the interest is 5%. So to get this amount, we took 10,500 and we multiplied by the 5%. And then how much do we get for that? $525. And so then we're going to add that to the 10,500, and so that's for that. So now to get year 3, we're going to take the previous year's amount and we're going to multiply it by 5%, and we're going to add it to what we have. So we're going to calculate the interest payment and then add that to our original amount. So how much will we have in year 3? So 11,000. 576. Alright, so then we're going to take this amount and we're going to add the 5% interest to it. So is it going up the same amount each year? Alright, is it increasing more or less each year? Right, so each year, as we have more money in there, we're getting more interest, right? Or, well, Madison is anyway. To the nearest cent. So it was 25. So they can see our table values too. So our completed table where we are increasing. So Madison is given $10,000 and then she puts it into an account that earns 5% interest, and after 10 years, she now has $16,000, a little over $16,000, just for letting it sit. that's not bad, right? It's almost, it's, increased by 60% over 10 years. That's pretty good. So, questions on this? So, investment wise, that was a pretty good investment, right? So, let it go. I don't want to say anything and then spoil the next thing. All right, so the amount of money in the account increases by a constant growth factor each year. So each year it's increasing by 5%, right? So identify the constant growth factor to the nearest 100th. So what is it increasing by each year? How is the interest rate on medicine's account related to the constant growth factor? Well, it's the original amount plus 5%, right? Alright, so then this is taking that amount and it's kind of showing it how exponents are playing. So if Madison wanted to know how long, if she left it in the account for 20 years, how much money she would have. Instead of going out and creating a table going from 0 to 20, which would be time consuming, right? Even if we kind of sped it up using the 1.05, this is going to kind of break it down. So for year one, that would be the original $10,000 times the 1.05. And then for year two, it's year one amount times 1.05. And so we can write that using our rules of exponents as 1.05 to the second power. So how do you think year three, how that's going to look? It would be what we had for year one, right? So it would be $10,000 times 1.05 times 1.05, which that would be the year two amount, right? Times 1.05. So how could we write that? We have our $10,000 times 1.05, and how many times are we multiplying 1.05? To the third power. So then how could we write year four? 10,000 times 1.05 to the fourth power. Year five. How could we write that? And then year six. The sixth power. And so question 6 says, describe the relationship between the year number and the exponential power. So year 6, what's our exponent? 6, right? And for year 5, our exponent is for year 4, for 3, 2, 1. And then can I even say that this is 1.05 to the 0 power? Because anything to the 0 power is what number? 1. So the year equals the exponent. Alright, so it says write an expression for the amount of money that she'll have in her account after year 8. So how would that equation look? Alright, so Jordan said 10,000 times 1.08 to the 8th. Do we agree or disagree? And here's some grunts. Take it as we can agree. Alright. Number 8, let T equal the number of years, express regularity in repeated reasoning. Write an expression to represent the amount of money in the account after T years. Right? So just like a general expression, we know how much he's starting with, right? That's at $10,000. and we know her interest rate. It's that 1.05. And then in for the years, what are we going to put? T. So now it's asking us essentially to check it because we know how much money she has after 6 years. So to check this, if we do 10,000 times 1.05 to the 6th power, do we get the correct amount? I heard one. Do we agree? All right. And what was that amount? So Tom knows. 13,400. All right. So now evaluate the expression for 10 years. So just triple check it. This time we're going to triple check it for Michaela. So if we do 10,000 times 1.05 to the 10th power, what do we get? So after 10 years. And so it's checked. It's checked for 10 years and it's checked for 6 years. Oh, 96 cents here.
Yeah, I got
Oh, is this just a rounded one? 94 and 96 cents.
It's 134.00.96.
Let me just do that because I can't. Too many numbers. So 10,000 5 to the 4 and 96. That one. Is that what you guys said? Yeah. Okay. And that matches what we had on the table, right? All right. So write your expression as a function m of t, where m of t is the total amount of money in Matta's account after 10 years. T years. So m of t equals how much is she starting with? 10,000. And how much interest is she getting each year? And for 2 years. So now we have a nice equation that we can use to calculate how much money Madison has in her account at the end of each year. Alright, so now we're going to graph it. So we're going to use the information that we had in our table back at the beginning. So at 0 years, Madison has $10,000. After 1 year, she has 10,500, right? After 2 years, how much money does she have? 11,000. And then after 3 years? 11,500. And 4 years? 12,164. 5 years? 6 years? 7 years? 8 years?
14,773.
9 years?
15,511.
10 years?
65.
Alright, so is this linear or non-linear? nonlinear? And if it's nonlinear, what kind of function does it look like? That hint we've been studying. Exponential. So if Madison keeps the money in that account, so she had 10,000, which she started with, and then after 10 years, she has 16,000. The amount of money that she's earning for her on the account, is it going to keep on increasing? All right, so number 12, identify the reasonable domain and range. So domain, is that your input or output? Input. So what's reasonable numbers that we can put into our function? What are values that t can be? All right, so I heard different things. So I heard all real numbers. I heard positive numbers. All whole numbers. Um, all real whole positive numbers. um, so let's think about this. We're talking in years, right? Can Madison keep that money in for 2.5 years? Yeah. All right. So can she keep it in there for a third of a year? Yeah. All right. So we can have partial, right? All right. So can she keep it in negative years? No. So what would be a reasonable starting point? 0. So 0 is a good thing. And then where are we going from there? Are we going less than or greater than? Greater than. So domain X can be everything greater than or equal to 0. Could she keep it in there for half a year? Sure, why not? You're not going to get a lot of money, but some is better than none, right? And we can calculate how much half of the year of interest would be. All right, what about range? That's our y values, right? So looking at our y-axis, what's the shortest, or what's the least amount of money she's going to have in that account? So what's the least amount that our graph is going to have here? 10,000, right? She's not going to, the bank's not going to say, oh, we lied, we're going to take some of your money, because Madison's going to get down there and give them a piece of her mind, right? So the least amount of money that she's going to get out of that account is how much money? $10,000. So y is going to be greater than $10,000. Now, is there a maximum? No. Have you ever seen the show Futurama? Yes. All right. So how did the main character get his money? In the 20th century, he only had a few cents, right? But over the thousands of years when he was cryo-frozen, what happened to his money in the bank? I got more money, right? Because it kept building interest. And then in the future, he had loads of money, right? The athletic trainer is here. Thank you. So there's no limit, right? If Madison decides to be cryo-frozen, and in 2,000 years, she's going to have loads of money, right? And we can calculate how much money Madison would have in 2,000 years if she decides to cryo-freeze. So let's just do it for funsies. So if we have $10,000 now, and we want, what I say, 2,000 years.
Holy crap, that's like
So if we do this, yikers. It may be worth the investment. So 2.39 times 10 to the 46.
yeah.
So just keep in mind 6 is a million. Times 10 to the 6 is 1 million. So this is a lot of money, right? You want to stick around for 2,000 years. I keep myself So, questions on setting these up? All right, so we will pause there. So let me see.